Welcome back to this tutorial series. This will be the third and hopefully the last video in this series. We are still trying to introduce us to blockchain. So in the first video, we had a general overview of what blockchain is. In the second video, we were able to look at how blockchain works, and we could demonstrate that with JavaScript using the object-oriented programming pattern. Now what we want to do is to now move into blockchain proper. So we'll be looking at how to write smart contracts using Solidity programming language. So what are smart contracts? We already know what contracts are. So the regular contract or the traditional contract we know are papers where there are certain rules and regulations that must be met by the parties involved in that agreement, and that agreement defines how the transaction or relationship businesses happens between the parties involved. But smart contracts are a bit different because they are not physical papers that we need to sign in order to get work done. Smart contracts live on the computer and are executed by the computer. So smart contracts are code that lives on the blockchain, and they have predefined rules that must be met for the code to run. So if those rules are not met, the code will not run, or will not run as has been arranged for it to run. Solidity, on the other hand, is a programming language specifically designed in order to build smart contracts. So it's not like the regular programming languages we have, because building smart contract or building blockchain applications have specific rules, regulations that must be met in order for it to work properly. As you continue to learn, you will learn more about why Solidity is the language that most blockchain has been built on. You learn more about smart contract and all those. What we want to do now is to introduce you to Solidity as we use it to build basic smart contracts. Now, the smart contracts we want to build will help us to send money or funds from one wallet address to another wallet address. That's from a sender to a recipient. That's what we want to do. And like I said at the beginning, this is a basic course, so you don't have to be scared. Everything we're going to be doing is going to be very basic and introductory kind of stuff. We are not even going to be setting up any project. We'll be using an already designed playground that is called the Remix playground. It is given to us by Ethereum for us to test smart contracts. So I will share my screen now. Yeah, everything is going to happen on the browser. I'll share my screen and I'll open a new tab. It is remix.ethereum.org. So remix, I already have it here. As you can see, remix.ethereum.org. That is it over here. So once you enter that into your browser, you hit enter, it should take you to a playground. For yours it might take a while. I already used Remix here, so it didn't take much of a time compared to what yours might be, but sometimes it takes a while, and then when it's done setting up, you should be at this point. If you're not exactly at this point, click this button here. Yeah, it should bring you to this place, and if you notice, there is already a contract created for us here by Remix. Let me zoom in so that you can see what I'm doing. So this is, a dummy contract. It's not really doing anything serious. So we'll have to delete this and start. Yeah, we want to delete it. Now it's gone. So we want to build our own blockchain. So what we want to do here is, first of all, we are creating a new file. We'll name it blockchain dot sol. Sol is short for Solidity. So for every Solidity file you see, it should have the extension .sol. So you hit enter, it creates the file automatically, and that is it. We might close this a little bit, or let's get it off the screen so that we can now focus on here. When building blockchain, when writing smart contracts for blockchain like this, we always start with the licensing. I'll just paste this here. SPDX license identifier unlicensed. This is just us telling blockchain, or telling Remix Solidity that, hey, we accept the terms and condition that is required for us to be able to write smart contract. This must be on top. If not, it's going to throw an error when we run it, or you might even throw an error within your IDE. Then the next thing to do is to specify the Solidity version that I want to use. So we do pragma Solidity. You now specify the version. I'll use 0.8.7, and in order to make sure that this is future compatible, I'll just add a caret sign here so that we are saying that any version from 0.8.7 should be fine. So next we'll start building the contract. Now, like I specifically mentioned, the Solidity programming language follows the pattern of an object-oriented programming language. So which means like an object programming pattern, object-oriented programming pattern, it should have something like a class. But in Solidity, we don't use class like this. It doesn't work that way. In Solidity, we call it contract. After all, what are we creating? Smart contract. So it is only right that instead of class, it is called contract. And what is this contract? It's a blockchain contract. So let's write it there. Blockchain. And we open and close curly braces like we would do for a class. Awesome. Now, the next thing, the first thing we want to do inside of this contract, I'll just zoom in so that I'm sure you are seeing what I'm doing. Inside of this contract is to create a data type or some sort of data structure. What I was saying, we have a lot of data types like objects, arrays, maps, and all the type you can think of. But these are kind of restrictive. They restrict you to just maybe use a particular pattern, sort of. Now we are looking at how we can create a particular structure that really fits into what we need. So for us to do that, Solidity gives us what we call structs like this. struct helps us to create a structure of data that we want. So how it's done is you put in the data type first. Next thing you put is the name of the struct, and then you open curly and close curly braces. Now inside the curly braces, you now put in the data that you want to receive. Makes sense? Now something else I want you to notice that Solidity is a strongly typed programming language, which means you must specify the type of anything that you are doing. So if you're going to declare a variable, always enter the type first before putting the name of the variable. Just in the same pattern, we'll put in the struct first and then want to set up a block struct, more like the structure of our block. That's what we are setting up here. Awesome. Now, what and what do we need in our block? One of the things we need is the index. Next thing we need is timestamp. Then we need the amount to be sent. We need the sender and the recipient. Awesome. Like I told you, every variable you declare needs to have its type. So if we run this code like this, it's going to throw an error. So what we need to do is, in front of each of these keys that we have entered here, we'll add their data type. So what's the data type we want to use for index is uint. What is uint? Is basically integer. So we are saying that this index should be an integer. Now, this uint could be of different sizes. The highest, which is of course 256 like this. It could also be 18, different numbers depending on what we want to use it for. But by default, you could leave it as uint, and behind the scene it has 256, which is the highest number of size you can have. So let's leave it as uint. Then for the timestamp, we're using uint. For the amount, we are using uint. For the sender, what we want to use to send this money is the wallet address. So it's not going to be a string, it's not going to be an integer, it's going to be an address. So specify it. This is an address. Same thing with the receiver. We're sending it to the receiver's address. So what we need here is an address. Awesome. We will be sure to format this so that everything comes in line. Now a mistake we made is to use commas. Inside here we are supposed to use semicolon. So okay, cool. Add it here. Now let's get rid of this. Okay, let's add this here. Uint index. All right. Okay, that's okay. I think we have everything we need: the index, the timestamp, the amount. All right. Now, after the struct, next thing we want to set up is an event. What is an event? An event is like it's just like feedback that we send to the front end, something like console log too. Basically, after a function has been completed and an operation has been completed, we want to send certain feedback to the front end. It also helps in debugging. So events is usually defined like this. You put an event like this, that's the event keyword, and then what you specify the name of the event. We want to make it a block event, so block event. Now, unlike the struct, this doesn't use curly braces. It opens and closes the regular braces and also ends with a semicolon. Now, what are the things we want to return at the end of this function execution? The function we're talking about is the function that will add block to the chain that we will be creating. That is, that we're adding block to these blockchains that we are creating. So the first thing we want to return to the user is the amount, and an amount is uint, so put it uint amount. Next thing is the sender, so it's following the same pattern. Put the data type or the variable type before you put in the data that you are looking to add, and that is it. That is all you need to create an event. I hope that's making sense. After creating an event, now we are ready to create other things. We need to create two variables. One of them is chain, and a chain will be an array of block structs. So what we are saying is the blocks we will be adding to this chain is in form of this block struct. That is the block structure. But what we want to do is we want to have the chain hold every block that will be added into it. So in essence, it will be like an array of objects. Yeah, so that makes a lot of sense. It will be an array of objects, and that's what we want to create here now. So we are creating the variable, we are calling it chain. But if you recall, we said before every variable we need to specify the data type and then specify if it's going to be an array or not. Then another variable we want to create is the chain count. Chain count. Now this is going to keep track of how many blocks that has been added into a chain, and it's going to be a uint too. So all right. Okay, good. Solidity also have a constructor. You can also declare a constructor here. This should be in. All right, good. Okay, constructor. Now I could actually declare this chain count here and assign it a value at this point. Say something like equal to 0. It's all good. You could also do it inside the constructor. So we could set the chain count here and say equal to 0. So this constructor does the same thing that the constructor in JavaScript object-oriented programming pattern does. It runs a code once. So here it will assign this chain count value once, and then whatever is going to happen to the chain count wouldn't really concern it anymore because it has run the first time, and that's the end. Now after this, we are now set to add blocks to chain. So we'll be using the function keyword. We'll be using the function keyword here. So this is a little different from the object-oriented pattern that we did in JavaScript. Here, you need to spell out function. Then the name of the function. Name of this function is add block to chain. So add block will just suffice. Add block is enough. Well, let's complete it. Add block to chain so that it is very descriptive. Then in here, we need to specify what we are expecting, the parameters we are looking for. And what are those parameters? You need to enter in the amount. We need to also enter in the recipient. And the recipient is an address recipient. However, because this is a transaction, we want to specify that this recipient should be able to receive payment. So for that reason, we put in payable here. Yeah. So this basically tells Solidity that this recipient should be able to receive payment. Now, something else that is very important is the visibility of a function. We need to always show how we want that function to be accessed. It could be public, it could be private, it could be protected, it could be eternal. So for this one, we want it to be public. Public simply means that this function can be accessed by anybody from anywhere. All right. Now we are done with setting up the boilerplate for this function. Now inside here, the first thing we want to do is to increment the counter. That is this chain count here. What we are doing is we are keeping track of the block that we want to add. So the chain count here, we do a chain count plus equal to 1. So this will increment the count to if it was 0, which it increases it to 1. If it was 1, it increases to 2. And this will also form the index of this block that is being created. So when we want to look for how many blocks that have been added, we just return the chain count. Make sense? I hope so. All right. Now, in the chain, remember that the chain is supposed to keep track of every block. So we keep adding the blocks inside. And this chain is an array. So how do you add data into an array? We use the .push method. It's just like the regular array that you know. So we use the .push method. And inside the .push method, remember that every block is supposed to take the form of a block struct. So we set out the block struct here, open braces like this, and then we start filling in the data that we specified, the index, the timestamp, the amount, the sender, the recipient. All right. Now, what's the first thing? The index. We are using the chain count as the index. So it's chain count here. The next thing is the timestamp. We are using block. Now this is a special special method here in Solidity. Block.timestamp will give us the current time. Next thing we need to put in is the amount. So we're already getting the amount from here. So we just come here and put in amount. Then next is the sender. Now the thing in blockchain is you need to log in with your wallet address in order for you to make a transaction. So whenever you log in to make a transaction, Solidity gets the details of your login and whoever you are, your wallet address, everything from MSG. That should be short for message, something like that. MSG. So in MSG we have a lot of data. One of the data we have is sender. So like this, whenever you log in, maybe deploy a contract and you want to send money, the Solidity programming language helps us to get the sender, who is the person logging, and then the recipient will be entered just as it is passed in here. So we just enter it here, recipient. Beautiful. Now that's making sense. And once you've added it here, it becomes part of the blockchain. So we have an extra block inside the blockchain. After this, remember that we are supposed to emit an event. Like we pointed out, an event helps us to give feedback as to what happened during execution, or how the block was created, stuff like that. So after creating an event like this, the next thing is to emit it or trigger it. And the keyword used is emit. So what are we emitting? We're emitting the block event that was created. And what are the details of that event? The first thing is the amount. The next thing is the sender, which we get from MSG, the sender. And the last one is the recipient. Awesome. And that is it. That is how you are able to add block to the chain. Our block takes the form of the block struct. All right, good. We want to create some other functions. Creating this function will help us to demonstrate other things we don't know about Solidity yet. So returning data from a blockchain using Solidity takes a little different pattern from what you already know. In returning data, you need to specify what you are expecting in return. So let's do that by creating a function named getChain. Now what the getChain does is it returns the chain for us. That is, it returns all the blocks that has been added. So let's do that. Function getChain. It takes no argument, but we need to declare the visibility, which is public. Because it's going to return something, we are specifying that it's going to do a view. And then what is it going to return? We need to specify that. So we do a returns in brackets. We're expecting block struct, an array of block struct like this. Now, something else you need to specify is the storage. We have two storage types. One is storage itself, and then the second is memory. The storage is like a permanent storage for the program, while the memory is a temporary storage, and it is less expensive in terms of gas. What do we mean by gas? Now, blockchains or smart contracts require certain amounts to be spent while running it. It's not like the regular JavaScript code that we just run without spending nothing. it requires that we spend certain amount of Ethereum, and this is what we call gas or funds. Everybody knows it as gas. So what we are saying is the memory uses less money or less Ethereum compared to storage. Storage is really expensive. So what we are doing here is temporary. So we don't need storage, we need memory. So we have to specify the memory where this return data will stay, and that is memory. If I will spell that correctly, good. Now after specifying all this, just open and close curly braces, and like we said, we just want to return the chain. So we just return chain, and boom, that's it. Now this chain, like we specified, this chain is an array of block, so it corresponds to what is here. Beautiful. Now the final function we want to create is get chain count. Chain count like this. What it's going to do is to return the number of blocks that has been added. As usual, we need to specify the visibility. We're using public. It's going to have a view, and then what it returns a uint. That is it. It returns uint. Why is it returning uint? It's just a number, so uint, like that. And then we open and close curly braces like this, and like we did in the last function, we just return the chain count. Now you see why we were keeping track of the chain count, and that is all. Something about blockchain is that you need to use your semicolon a lot, so you need to specify places you need to end every line of code with semicolon. So please cross check just to be sure. All right. I think that is about correct for everything we've done. All right. We'll find out in a bit when we compile our code. If there is any error, we will get it. But let's do a recap. Yeah. Always begin your Solidity program with the licensing recognition. This is the same thing anywhere. So you could just copy and paste it. Then specify the Solidity version that you have to use, or you need the Remix playground to compile your code with. Whatsoever place that you're compiling the code, you need to specify the version of Solidity you want it to be compiled with. Then you start your contract with the contract keyword. After that, you name the contract. Of course, we named it blockchain. You create your struct. If you need more than one struct, you have to create and repeat. They are following the same pattern. So you can achieve that once you are able to specify or decide what structure you are looking for. Next, you specify events. Events, like we pointed out, are like feedback to the front end. So if you're connecting this to the front end now, you start seeing maybe uses of some of these events that were created here. After that, we declared variables. The first variable we created was chain. And we said that chain is an array of block structs. The second variable is chain count, and chain count is an integer. Remember, we use uint for integers, we use address for wallet addresses. And like we pointed out, we could actually assign value to chain count here, but to see how constructor works, we had to declare constructor here and then set value to the chain count here. Next, we created the add block to chain function. Always remember that before every variable, you need to specify the type and then specify the visibility. If not, you might get an error. So always specify the visibility. Inside of the add block to chain, we first of all increase the number of the count, just so that we know that we are adding one more block. And then we added the block proper here using the block struct pattern, or the block struct structure. Yeah. After adding the block to the chain, we emitted the block event that we created here. Then we went ahead to create the get chain and the get chain count. Remember, if you are returning a data, you need to specify that this function is doing a view, like reading from the storage or the memory, and specify what it returns. This returns an array of block structs. For this, it returns a uint. And that was it. Beautiful. I hope you've been able to learn a few things about Solidity. Don't worry if you feel like this is a lot. You just need to go through the tutorial a couple of times, and it gets better, it gets easier with time. Awesome. Next thing we want to do is to compile our code. Now, after creating, it's important to compile. During compilation, we'll check and we'll see if we've made any mistake and see how we could correct the mistake. So you come to the side menu here and take the third icon here, click on it, and you can expand a little bit here. Let me reduce this a bit. Okay, let's expand this. All right. So something you will notice here is that my compiler matches the version of Solidity that I picked. Make sure that this compiler matches. So I'm here in 0.8.7. Always make sure it matches, especially if you're not using the caret sign here. Then click on compile. Now everything compiled properly. That if it didn't compile well, we will have gotten some errors here. So kudos to that if you also compile. If it didn't compile, please go through the code to make sure that everything works properly. Now after compilation, we now want to test the program that we have created. And so we go down to the next icon here, which is deploy and run transaction. You could expand this a little bit in case. First thing first, choose the environment you want to deploy this. So I'm choosing Remix VM London. This will automatically give me 10 accounts here. Remember that we are supposed to use gas. Yes, we're supposed to use gas. That's some Ethereum. But instead of buying real Ethereum, we'll be using dummy Ethereum here. So here are 10 accounts with 100 ethers each. These are fake Ethereum, but they'll help us run our code. All right? Good. You don't have to bother about all this. Now you just need to come down here and click on deploy. Before you click on deploy, you could check down here and look at deploy contract. You'll notice that there is no contract here. You say currently you have no contract instances to interact with. Once you click the deploy, you should have one contract here that has been deployed for you to interact with. Boom. Voila. Now if you look down here, you notice that we have one contract here under the deployed contract. Now this is an instance of this contract, just like when we were doing the tests for the blockchain we created with JavaScript. we created an instance first. So let's interact with this to see how well our code works. So you click on this arrow by the side of this contract that I want to test. So click on it, it drops. Let's scroll up. Beautiful. Now you notice that I have 3 buttons here. Each of these buttons matches the 3 functions that we created. Remember that we created 3 functions: add to blockchain, and that is it here; get chain, that is it here; get chain count, this is it here. So what Remix does is, as soon as you deploy your contract, it helps you to create an interactive interface, like a front end, for you to be able to test whatsoever code you have written. So let's do the actual testing here. Because this is an input box which could actually input what you want to add here, but that might not be necessary. You could drop the form like this too, which I actually prefer. You could try any one. So we want to send a 10 ethers, and the recipient. Now for the recipient, you can come up here and pick. You can pick any of these other addresses. Now, something I want you to notice here is that the first address is no longer 100 ether. The reason is we have deployed this contract. And like I pointed out, you require gas or ether in order for you to do anything here on blockchain. So that's why we have less than 100 ether here. It has used a couple of ether, which is less than 1 ether, and it's a good price. So we still have 99.999. So I will just select a different account so that I'll be able to copy it. You copy it and then return the first account to where it is, because that is what you use to deploy the your contract. So we'll paste the address that we got in this second part, that is the second input box, and we'll click on transact. Now this was successful. Now let's check the chain count. Chain count should not be 0 now. So click, boom, we have 1. If you check the chain, it should return a lot of data. Now, if this data is well arranged, you notice that it contains the address we added. It contains the amount we want to send here. It also contains timestamp and a few other things. We could add one more, so we could do let's change this to maybe 14 ether. Let's use the same address again. Click on transact, boom. Now if you click on get chain, you should have 2. Look at it, that's awesome. And if you click on get chain, the data should be bigger than this because you have an extra block. Boom, that is it. The data is now bigger than what it is before. Awesome. And that is how you build smart contracts. It is that easy to start building smart contracts. You can build smart contracts for a lot of things. You could think of gaming, you could think of market like NFT, you could think of, the list is endless. So you just need to start building from what we have learned. What we have learned is the basics of everything you are going to be doing in smart contracts. So all you need to do is practice. Something I will do is also to add a few projects I think you can try out that will help you get better at using Solidity. I should add that in the comment section. I'll also add the remix.ethereum.org then comment section so that you could access it on your own. But I hope you've been able to learn the basics of blockchain so far, everything you need to get started. Now, you might not be able to build full-fledged blockchain applications with what we have done, but it gives you somewhere to get started and move from. So with the basics we've gotten, I hope I've been able to bring down the barrier of entry into the blockchain world so that you'll be able to go into the Web3 world and explore all the beautiful things that you can achieve here in Web3 and the blockchain world. I really enjoyed creating this tutorial. I hope you also enjoyed following me through from the first video to this video. I hope to create more of videos like this, and I hope to see you in those videos as I create them. I'll be dishing out more content, so please subscribe. Do not forget to subscribe, share, like, so that more people will be able to see this. And I'll see you some other time. Thank you for watching.